as the university.
Yeah, but still they are facing problem for billing salaries.
Oh my God. Okay.
I left 3 years back.
Yeah. Okay. So you directly went to Libra.
Liberia.
Liberia.
Yes.
Okay. What about
the college only I came to them, but they didn't give salary for 1 year, sir.
Oh my God.
Yeah, 150 members they left.
Oh.
How is about a bit?
Yeah, it's good, sir. It's good.
How many students?
Now we are having around 12,000.
Oh, 12,000?
Yes. It's now 6 years old.
Yes.
It's a good strength.
Yes, sir. Which location, sir, actually?
This is just 10 kilometers from Vijayawada city.
Oh, you are staying in Vijayawada?
No, nearby college itself. There is one small village.
Okay, but they are not providing the guest houses, sir, for faculty.
Still they didn't start to build it.
Okay.
It is in the proposal, but first they are giving the facilities to the students.
Okay, sir.
Then they will start, sir.
Oh, okay. 1,000 students means very huge campus, sir.
Yes, sir. Still they are expecting a few more. In this forthcoming academic year, because outgoing student strength is less.
Yeah.
Admission strength is, I think it will be high.
Yes, sir. I guess. Same as with facilities, sir. Everything is.
Yeah. Everything is same, sir.
When you joined?
I joined now 3 more months to complete 2 years.
Oh. That's good, sir. Don't go anywhere else, sir.
Yes, sir.
Thank you, sir.
It's good for good environment for research. Yes. and working culture, and students also.
Who is BC, sir? I'm in future. I may, because of my children education, I'm planning to come to India, sir. Let's see, sir.
Sure, sir. Sure.
Yeah.
Shall we start, sir? Now around 30 members join.
Yeah. No problem, sir. You can start.
Yeah. Good morning, everyone. I would like to call Manisha to introduce about the resource person.
Am I audible, sir?
Yes.
Madam.
Hello, everyone. A very good morning to one and all present here. Hope you all are doing well. We welcome you all to the one-day national level activity on learning techniques on handling digital images, organized by School of Computer Science and Engineering, Vittepi University. And the faculty coordinators of this session are Dr. Kuppuswamy P., Associate Professor, School of Computer Science and Engineering, Vittepi University, and Dr. Mahfooza Munawar, Associate Professor, School of Computer Science and Engineering, Vittepi University. This session will cover one of the emerging topics of machine learning techniques for image classification. Now, let me take a privilege for introducing today's guest, our keynote speaker, Dr. Asadi Srinivasulu, sir. Dr. Asadi Srinivasulu completed his BTech in Computer Science and Engineering from Sri Venkateshwara University, Tirupati, and completed his MTech in Intelligent Systems from Indian Institute of Information Technology, IIIT, Allahabad, Uttar Pradesh. He received his PhD from JNTU, Anantapur. Currently, he is working as a professor of IT and Head Research Data Science Research Lab, Bluecrest University, Monrovia, Liberia. He has got 20 years of teaching and industrial experience. He has received so many awards And one of the award is Bharat Vidya Ratan from International Business Council Delhi in 2018. And Lifetime Achievement Excellent Award 2022 and Outstanding Teacher Award 2022 received from Research Indian Foundation for the academic year 2022 to 23. And Best Mentor for the DGMC project for the years 2010 to 2012. And his area of interest includes big data analytics, data mining, data warehousing, artificial intelligence, cloud computing, Internet of Things, pattern recognition, machine learning, and software engineering. He is a professional member of CSI, ACM, NASCOM, ASGF, and the Indian Congress Association. And he is also an editorial board member of iManager's Journal on Cloud Computing. He has editorial board membership of SCI-ERA Journal of Computers. He has published more than 125 papers in international journals and conferences. He has attended more than 175 workshops, symposiums, and seminars. He has conducted and acted as a resource person for more than 125 international journals and conferences, workshops, symposiums, and seminars. Such an eminent person is available with us today. So listen to Sir carefully and follow the section. I kindly request you to take over the session, sir.
Thank you, madam, for nice introduction. Thank you, sir, coordinator, sir, Dr. Swami, sir, for inviting me for this one-day national level FDP faculty development program on machine learning techniques for image classification. See, nowadays, machine learning is a emerging and very good buzzword in the industry in order to develop all automation applications, especially in healthcare data analytics. We are using machine learning and deep learning and artificial intelligence techniques, especially for image, biomedical image health classification algorithms. And today I'm going to cover various topics in machine learning and three approaches like supervised learning, unsupervised learning, and reinforcement learning. And before going to my topic, if you have internet, you can check within 60 seconds what is happening. How many users are connected to this internet world? Can you imagine such a huge number of internet users connected to this world? If you see 6,94,444 hours watched in the Netflix, 3.8 million search queries, 1 million logins, Facebook, 18.1 million text sent, 4.5 million videos sent, videos viewed, 1.8 million emails sent. Likewise, if you click this URL, www.internetlivestats.com, so you will get the huge numbers. See here, internet users in this world. Can you read this number? Very huge number. If you have internet, you can type www.internetlivestats.com. So you will get total number of websites opened in this second, email sent today in this second, Google searches today, blog post written today, tweet sent today. These are the huge number of internet users are connected to this world. So where the data is coming from, how you are storing the huge volume of data in the servers, how many servers are required to store huge volume of data. These are the questions you may get doubt. To solve these sort of questions, we are going to use cloud computing technology. Cloud is an internet-based technology, pay and use. The backbone of cloud computing is data center and virtualization. Data center is nothing but collection of high integrated computing servers at one place is called a data center. And the virtualization is the ability to perform multiple tasks in a single system is called virtualization. with the help of virtualization technologies like VMware, hypervisor, Zen, Virtualization, we are creating the n number of virtual machines in a cloud environment. The best consumer of cloud computing is Gmail. If you open Gmail anytime, anywhere, 24/7, it is giving service. Why I am explaining? Because huge number of internet users are connected, and the data is flowing between server to server, computer to server, network to network, data center to data center. That's why the backbone of this internet live stocks platform is data center and the cloud computing. Traditional servers are not enough to store huge volume of data. That's why we are using cloud data centers. So if you see same thing I have incorporated in this slide itself, how many users are connected to this internet world, where the data is coming from, how many servers are required, how the data is represented in the servers or system or data center, etc. So now, see, actually, 1 week program used to conduct data science. There are covering the 8 subjects. First and foremost, data science, introduction to data science, or statistics, artificial intelligence, artificial neural networks, machine learning, virtual reality. So, machine learning. That's why I'm using the each one sector. My data science, how I have applied this classification. So before going to my system cannot understand capital E or capital Q because internally it converts into ASCII format. ASCII stands for American Standard Code for Information Interchange. Capital A ASCII value is 65. If you divide it by 2, you are getting binary equivalent number of 65 is 100001. So that means computer understands only ones and zeros. Now see the measuring the data, machine learning or computer science or information technology field. 1 bit is equal to 0 or 1, 4 bits is equal to 1 equal, 8 bits is equal to 1 byte, 4 bytes is equal to 1 word, 4 words is equal to 1024 bytes, 1024 bytes is equal to 1 kilobyte, 1024 kilobyte is equal to 1 megabyte, 1024 megabyte is equal to 1 gigabyte, 1024 gigabyte is equal to 1 terabytes. After that, petabytes, exabytes, octabytes, zettabytes, yottabytes. Hi, I am Robo. My speed is 1 terabyte and my memory is 1 zettabyte. Before that, Robo would be, we don't know the terminology frequently. After that, Robo we came to know there is a terminology presented in the computer's world. So that is 1 zettabyte and 1 yottabyte. Thanks to Director Shankar sir and Rajni sir, they have introduced that terminology, quite famous. So 1024 yottabyte is equal to 1 brontobyte. Yesterday night again I have checked the terminology about the data. Yes, there are 2 more new terminologies presented. 1024 yottabyte is equal to 1 brontobyte. 1024 brontobyte is equal to 1 geobyte. 1024 geobyte is equal to infinity. This geobyte is GEO, not JIO. That geo is ruined students' life and spoiled students' life. Students are addicted for a geo service. Initially, they are giving free of cost. After that, they are charged. So this geobyte is different. 1024 protobyte is equal to 1 geobyte. 1024 geobyte is equal to infinity. And if you see same terminology in mathematical, 1 kilobyte is 10 power 3, 1 megabyte is 10 power 6, 1 gigabyte is 10 power 9, 1 terabyte is 10 power 12. See in big data range, petabyte is 10 power 15, exabyte is 10 power 15, zettabyte is 10 power 21, petabyte is 10 power 24, protobyte is 10 power 57, geobyte is 10 power 30. So this is the numerical data in machine learning. And today I am going to explain various concepts in machine learning. Machine learning is nothing but learning from the observational data by using the supervised learning, unsupervised learning, and reinforced learning. In supervised learning is nothing but there is a target class label. Based on the target and label, we are classifying the data with the help of linear regression, logistic regression, support vector machine, nonlinear regression, decision tree, random forest, k-nearest neighbor, artificial neural networks. These are the supervised learning. Then unsupervised learning means there is no data, there is no target class, but I would like to classify the data based on the similarity measure that is called clustering. Based on the supervised learning, we are classifying the data by using clustering techniques called k-means clustering, c-means clustering, Euclidean distance, elbow method, fuzzy c-means, agglomerative clustering, density-based clustering, and there are various unsupervised learning concepts I am going to demonstrate. The third one is reinforcement. Reinforcement learning is nothing but based on the punishment and reward. We are solving the various applications, especially automation applications by using artificial intelligence, especially in gaming applications. We are using reinforcement learning. In order to implement the gaming applications, we are using SARSA reinforcement learning techniques, Euclidean, DDPG, and APC. These are the popular gaming reinforcement learning algorithms I am using for demonstration purposes. And so this is an overview of machine learning. Today I am going to give you introduction to machine learning. In order to classify the images, I am using the Python programming. So how to write code in Google Colab, Jupyter, PyCharm, ideally I am going to demonstrate. Then supervised learning, these are the concepts I am going to demonstrate. And unsupervised learning, and especially unsupervised learning association, market basket analysis using a priori algorithm, market basket optimization analysis using the Euclidean association algorithm, and followed by the reinforcement learning, natural language processing. In natural language processing, study of different languages, study of linguistics by using artificial machine learning, deep learning techniques. So here I am going to demonstrate sentiment analysis using natural language processing, breast cancer image, X-ray image tumor prediction using XGBoost. And deep learning is nothing but is learning from the observational data with a deep manner by combining the huge number of input and hidden layers. So here I am going to classify PIMA Indians diabetes classification, COVID-19 image data detection using convolutional neural networks, and artificial intelligence snake game using reinforcement learning. So this is the syllabus today I am going to demonstrate. And so what is meant by machine learning? Machine learning is nothing but learning from the observational data. And it is a branch of computer science, study of computer algorithms that improve automatically through experience. and can learn and adapt new data without human intervention. So machine learning is a branch of computer science, in artificial intelligence. It provides smart alternatives to analyze vast volumes of data by developing fast and efficient algorithms and data-driven models for real-time processing of data. They are using machine learning to produce accurate results and precision and analysis. The field of machine learning is concerned with the question of how to construct computer programs that automatically improve the experience. This great definition given by the top lecture. You see, my dear participants, can you name it? What is the technical name of this image? By seeing this image, you may get doubts, sir, it is related to machine learning. Yes. And how you are publicizing about the Vellore Institute of Technology, AP, at the Vijayawada, by using pamphlets, by using SMS, WhatsApp, Instagram, Facebook, banners, scorecards, everything you are using. In that category, this image also comes up. Can anyone know what is the technical name of this image? My dear participants, anyone can answer in the chat box.
Word cloud.
Fantastic. It's a word cloud. It is a one more way of publicizing about the organization, about the technology, or about any tool or anything. See, I have incorporated in this image tools, communication, artificial intelligence, programming, pattern recognition, supervised learning, unsupervised learning, enforcement learning, everything I have incorporated. That's why the technical name of this image is called machine learning word cloud. Fantastic answer. And how do machine learning algorithms work? You see, these algorithms utilize variety of techniques to handle large amounts of data, especially in complex data, to make decisions. These algorithms complete the task of learning from data with specific inputs given to the machine. Maybe text data, maybe audio data, video data, image data, etc. So the machine learning life cycle follows the training the model. Model means simplified version of the reality. Model creation, prediction, analysis, retraining. It is not showing good results. Then prediction is the life cycle of any machine learning algorithm. This enables us machine learning algorithm to learn on its own and produce an optimal and accurate answers that gradually increase especially in accuracy over the time. So if you see machine learning, you are having three approaches like the supervised learning. I have explained already. Supervised learning is nothing but there is a target class, there is a label. Based on that one, we are classifying the data, especially regression classification. Regression techniques are decision tree, linear regression, logistic regression. Classification techniques are naive-Bayes, support vector machine, k nearest neighbor. See, unsupervised learning. So there is no label, there is no target class, but we are dividing the classes based on the similarity measure by using Euclidean distance. Square root of x1 minus x2 whole square plus y1 minus y2 whole square. This is called Euclidean distance in order to measure the similarity measure between the points, especially in clustering techniques. And there are two types we are using clustering, dimensionality reduction. In clustering, we are using k-means clustering and k-medoids. Then a dimensionality reduction, we are using face recognition applications by using principal component analysis, feature selection, linear discriminant analysis, LDA. Then a reinforcement learning. Based on the punishment and reward, we are solving the gaming applications. There are various algorithms like DDPG, SARSA, etc. So what is meant by introduction to machine learning? See here, It is a subfield of artificial intelligence. Intelligent behavior in a machine is called artificial intelligence. The science and engineering to design to develop various intelligent applications. So the goal of machine learning generally is to understand the structure of the data and fit the data into models that can be understood and utilized by the people. See the steps involved in this machine learning. First, we are taking as an ordinary system as input with AI. Then machine learning, it learns and predicts and it improves the accuracy. Then the machine learning is the study of computer programs, especially computer algorithms, machine learning algorithms that leverage algorithms and statistical models to learn through inference and patterns without being explicitly programmed based on the tools and techniques we are performing. See, I have explained the types of machine learning, supervised learning. All data is labeled and the algorithms learn to predict the output from the input data. That's why it is called a task-driven. Unsupervised learning, all data is unlabeled and the algorithms learn to inherit structure from the input data. That's why we can call it as it is data-driven. And reinforcement learning, it works on interacting with the environment, whereas the supervised learning method works on given sample data or example. It learning from the errors. Based on the punishment and reward, we are solving the problems. So machine learning is important because it gives the enterprises a view of trends in customer behavior and business operational patterns. Pattern is a model. Model is nothing but a simplified version of the reality as well as supports the development of new products. So supervised learning, the algorithm learns the relationship between specific inputs like audio, video, text, graphics, images, and outputs based on the training data and the human data. So that's why we are using regression and the classification. In order to generate future trends, we are using regression and classification techniques. Unsupervised learning, the algorithm analyzes the data from trends and patterns without being given a specific output variable or human feedback. That's why we are using clustering and dimensionality reduction in order to solve various unlabeled data images. Reinforcement learning, the algorithm learns over time to maximize returns based on the rewards it receives per performing certain actions. That's why we are using model-free and model-based punishment and the reward concept. Especially we are using leading equations. Then what do you want the machine learning system to do? My dear participants, if you are having any doubts, please ask me. I'm going to clarify. So machine learning is a type of artificial intelligence that allows software applications to become more accurate at predicting outcomes without being explicitly programmed to do so. Based on tools and techniques, we are solving all the applications. So this, especially machine learning algorithms, use historical data, that is legacy data, old data, of suppose 10 years old data, that is called historical data, as input to predict new output values. So that is called future trends. You see how this machine learning system to do. I want to see if there are natural clusters or dimensions in the data I have about different situations. Then go for unsupervised learning, maybe appropriate. That is called a clustering anomaly detection. I want to learn what the actions to take in different situations. Then go, do you want the machine learning system to be active or passive? So as active, the system's more actions will affect the situation it sees in the future. Passive, the system will learn from data I get. Okay. So do you want Do you have access data that describe the lots of examples of situations and appropriate actions for each situation? So, like that, would there be patterns in this situation that humans haven't recognized before? No, supervised learning may be appropriate. Do we have access to data that describes a lot of examples of situation and appropriate actions for each situation? If it is no, then go for machine learning is not useful. Will the system be able to gather a lot of data by trying sequence of actions in many different situations and seeing the results? If it is yes, then go for reinforcement learning may be appropriate. If it is no, go for machine learning is not useful. So this is about what do you want the machine learning system to do. So these are the types of machine learning approaches. Supervised learning based on the task driven, unsupervised learning based on the data driven, reinforcement learning based on the learn from mistakes or errors. So machine learning process involves making systems that learn and improve by themselves by being specifically programmed. The ultimate goal of machine learning is to design algorithms that automatically help the system gather data and use that data to learn more. See the big data I'm taking as an input data, audio, video, text, image data, and training data and making a big model. Then taking the decision in the application. So learning and inference. Okay. Then see the machine learning life cycle. The steps: data gathering, data preparation, data wrangling, data analysis, model training, model testing, deployment. These are the 7 steps are involved in this machine learning life cycle. Then how does machine learning work? See here. So machine learning is a form of artificial intelligence that teaches computers to think in a similar way to how humans think, especially learning and improving upon past experiences. It works by exploring data and identifying patterns and involves minimal human intervention. You see input data, maybe audio, video, text, graphics, animation data. Then analyze the data, find patterns, prediction, stores the fit. So how does machine learning work? This is the steps we are follow. Then machine learning examples. If you see, machine learning would be trained with pictures of dogs. This is example. And other things, all labeled by humans. And the machine would learn ways through identifying pictures of dogs on its own. This is the example for the machine learning. There are various examples like self-driving cars, predicting an illness, predict worthiness, ranking on social media, computer vision in agriculture, targeted emails, and question and answer space platform, and the fashion industry, targeted emails. Then see one more example I'm going to explain, reinforcement learning. So there is a problem called see, there is a fire, there is a bucket full of water, and the right side there is a fire. So environment and intelligent agent is a robot. Now, according to the instructions, a robot agent perform the actions. So agent is observing right side fire, left side full of bucket with full of water. So as a user, you are giving instructions to the intelligent agent. First observe, select the action using policy. So third step action. Suppose it went right side and the agent hands up. So which 50 points we are reducing. Then fourth step, get reward or penalty. We are giving penalty for this intelligent group. So update policy, learning step. Fire is equal to that. Then next time provide. I'm giving next. Then then intelligent agent iterate until an optimal policy is formed. So, this intelligent agent taking good step after punishment. That's why it is called reinforcement learning. My dear participants, this is the best example for reinforcement learning. These are the steps we use to follow. Then these are the machine learning approaches like algorithms, supervised learning. We have regression and classification. Unsupervised learning, we are having clustering, association rule mining, dimensionality reduction, and ensemble learning, we are having stacking, bagging, boosting, natural network, neural networks and deep learning, we are having convolutional neural network, recurrent neural network, generative adversarial network, and autoencoders, perceptron, etc. Then reinforcement learning, we are having algorithms like Q learning, DQN, SARSA, genetic algorithm, A3C. So these are the machine learning approaches. See, predictive analytics strategy is nothing but it determines the likelihood of future outcomes using techniques like data mining, extracting meaningful interested pattern from the huge volume of data. Then statistics, data modeling, artificial intelligence, and machine learning. Put simply, predictive analytics interprets an organization's historical data to make predictions about the future. See the predictive analytics strategy, reprocessing, Euclidean data set. So we are extracting feature selection, modeling, simplified version of the reality, 5-fold cross validation. Then telecommunication available data set, feature selection, modeling, 5-fold cross validation. Michigan plus telecommunication data set. They are doing feature selection, modeling, training, and validation. This is about the predictive analytics strategy. You see, in traditional approaches, the parameter values are fixed based on the statistical calculations. In machine learning, the parameter values are fixed in the process of training the model. So model is nothing but simplified version of the reality. You see, traditional programming or machine learning, machine learning. So data program they are giving as a input to the computer, it gives the machine learning data and output they are giving to the computer, it gives the model. Model means simplified version of the reality. We see traditional model, prediction, data and the handcrafted model. You are giving to the computer, it gives the results. Machine learning, we are taking sample data, expected results, new data, and gives input to the computer, it gives the model and results. This is about the traditional approaches versus machine learning. See, traditional approaches, the parameter values are fixed based on the statistical calculation. Machine learning, the parameter values are fixed. The process training the model. So for training purpose, 75% we are using images, 25% we are using for test. Types of machine learning algorithms, see supervised learning. We are having classification under that, fraud detection, email spam detection, diagnostics, image classification. Then regression, risk assessment, score prediction. Unsupervised learning, deep dimensionality detection. We are using text mining, face recognition, big data visualization, image recognition, etc. Clustering, biology, city planning, targeted marketing, etc. Reinforcement learning, we are using gaming, finance sector, manufacturing, inventory management. Reinforcement, robot navigation, etc. The 4 different types of machine learning algorithms we are using: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement. Semi-supervised learning is based on the combination of supervised and unsupervised learning, it becomes semi-supervised learning. So these are the algorithms, machine learning. Take regression, linear polynomial, classification, k nearest neighbor, trees, logistic regression, naive Bayes, support vector machine. Busy clustering comes under unsupervised learning, support vector dimension, principal component analysis, k-means list. Association analytics, a priori algorithm, frequent pattern growth algorithm, hidden Markov model, HM. So that is reinforcement learning. There are two types, continuous and discrete category. Then machine learning algorithms. You see supervised learning, data with label, classification and regression. If we take classification example, email spam detection, speech recognition. Regression, stock market prediction and rainfall prediction. In the unsupervised learning, data without the label, that is called clustering. Examples like identifying fake news, document analysis, then association rule mining, a priori algorithm, FP growth, Euclid, examples market basket analysis. See dimensional reduction like feature extraction, principal component analysis, feature selection, wrapper, filter, embedded method. An example analysis of written text and DNA microarray data. Then reinforcement learning, state and action, a model tree, Q learning, policy optimization, B model based, etc. Then these are the machine learning approaches I have explained already. Various techniques, regression like regression trees, Bayesian networks, fuzzy classification, artificial neural networks, etc. Then these are the various approaches of supervised, unsupervised, and reinforcement learning. Reinforcement learning, real-time decisions in AI, tasks, skill acquisition, robot navigation. So this is about learning reinforcement learning. So machine learning algorithms, like linear regression, class or classification and regression trees, k nearest neighbor, machine learning, support vector machine, Q learning, linear discriminant analysis, logistic regression, naive Bayes, learning vector of organization, bagging and random forest, posting and adaptation. Machine learning tools like statistical mathematical tools like R, Scilab, SAS, SPSS, PSPP, statistical models, SciPy, NumPy, etc. General purpose, we are having various tools like scikit-learn, data-tree, rapid miner, MATLAB, create, apply, and Shogun. And the narrowed solutions like XGBoost, Bhopal, Rabbit, Lip, Linear, RIC, SVM, NLT, NLTK, Genome, Tensing, interactive platform, Jupyter, Zeppelin, Orange, Kibana, Grafana, Tableau. Then see machine learning, deep learning with MapReduce, and deep learning with the GPU, graphical processing unit, deep learning wrapper libraries. These are the various tools we are using. This one we have executed. Then any doubt, my dear participants? Please respond, any doubts? Is clear? Please respond, anyone, if you are having any doubts.
Clear, sir.
Okay, thank you. Machine learning algorithm roadmap, CML engineer after your course or your graduation, you are becoming a machine learning analyst or machine learning engineer. So you have to follow the steps like this. You need to have a mathematics background, like probability, statistics, discrete mathematical structures, programming like R, Go, Java, Python, etc. Databases like MySQL, SQL, Teradata, DB2, Mongo database, etc. Machine learning, then we are applying scikit-learn, supervised learning, unsupervised learning, and reinforcement learning. Then we are applying machine learning libraries like and non-machine learning libraries. Machine learning algorithms like linear regression, logistic regression, nonlinear regression, KNN, K-means random forest, and more. Then deep learning, TensorFlow, Keras, neural networks, CNN, RNN, and GAN, generic adversarial networks, long short-term memory system, LSTMs. Then data visualization tools, Tableau, ClickView, Power BI. Then finally, machine learning. Machine learning analytics tools like developer tools like statistical platforms, pandas, exploratory data analytics tools, predictive model, markup language, EM, then scikit-learn, machine learning model builders, portable format for analytics, Mongo database, scriptable databases, Hadoop, MapReduce, Storm real-time analytics, Spark, iterative analytics, and field programming generally. And if you see GPUs and co-processors, etc., these are the tools. These are the machine learning tools: Keras, PyTorch, 9, RapidMiner, Jupyter, etc. And open neural networks, Apache Spark, came to machine learning tools like TensorFlow, Keras, etc. Machine learning softwares like Deka, Waikato environment, knowledge for analysis. Deka came from NECA. NECA is a flyless code at New Zealand, and the two professors, they have invented this Deka tool for data analysis purpose. Apache Spark machine learning library, RapidMiner, H2O, Shogun 9, Goa, RX2, Apache Mahout, PyTorch, TensorFlow, Keras. These are the machine learning algorithm tools. Advantages like easily identifies trends and patterns. First advantage, no human intervention based, continuous improvement, handling multidimensional and multivariate data, wide applications. We see disadvantages like a high error susceptibility, data acquisition, time and records. So if you see disadvantages like interpretation of results, time and results, resources. So these are the applications of machine learning applications: image and speech recognition, classification, medical diagnosis, prediction, statistical arbitrage, extraction, learning associations, regression. So these are the various applications of algorithm, machine learning algorithm. Automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual personal assistant, email spam and online filtering, self-driving cars, product recommendations, traffic predictions, speech recognition, image recognition. So these are the various formulas we are using in the machine learning, like naive-bayes, perceptron, linear regression, k-means algorithm, neural networks, principal component analysis, support vector machines, and broad propagation, and logistic regression, gradient data set. Gradient descent is one of the deep learning techniques. So major challenges faced by machine learning, like poor quality of data, underfitting of training data, overfitting of training data, and lack of training data, imperfections, algorithm maintained growth, physics challenges, insufficient data, poor
No, you are not in the session.
Poor generality of the algorithm, poor model interpretability. These are the challenges. Still, R&D is ongoing. High degree of specialization, insufficiently. These are the various major challenges. Then machine learning code libraries. See here Python libraries for machine learning. The year 2020. You can add 2023. Now. NumPy, SciPy, Scikit-learn, Theano, TensorFlow, Keras, PyTorch, Pandas. Why Python for NLC here? More flexibility, visualization ability. Code simplicity and platform independence, better libraries, larger community. These are the reasons why we are using Python for machine learning. Top machine learning algorithms predictions. See, linear regression type. The best fit line through all data points. Easy to understand. You can delay. See what the biggest drivers of the model are. Disadvantages, sometimes is input. And logistic regression, adoption for linear regression, problems for a classification. You see, decision tree is a classification technique. A graph that uses breaching method to match all possible outcomes of a decision. Easy to understand and not often used. The best goal of progression. And if you see this top 10 algorithms, random forest, gradient boosting, neural networks. 10 plus most popular machine learning software tools and comparisons. See, Scikit-learn. You can run platform like Linux, Mac OS, Windows, cost free. Written in language Python, Cyta, C, C++. Algorithms for features, classification, regression, clustering, processing, model selection, dimensional reductions. PyTorch, you can run Linux, Mac OS, free. Python, C++, code. And TensorFlow, this Linux, Mac OS platforms, free. Python, C++ code provides a library for data flow program. Backup can run Linux, Mac OS, Windows, free. Java, data preparation, classification, regression, clustering and visualization. And Backup is a free and written in language Java. Algorithms, features, data preparation, classification, regression, clustering, visualization, association. See, Nine is a tool can run Linux, Mac OS, Windows, cost is free. Written in language Java. Algorithms can work with large data volume, support text mining and image mining through plugins. Cloud services free, supports libraries of Python, Keras, TensorFlow, OpenCV. Cross-platform, free Java and Scala. Pre-processing, regression, clustering, recommendation, distributed linear. And Apache Mahmoud cross-platform, free Java Scala. Preparation, pre-processing, regression, clustering, recommenders, distributed linear. Across cross-platform, free and C#. So classification, regression, distribution, clustering, hypothesis test. Then the last comparison title is Shogun. Shogun is a tool, machine learning tool, Windows, Linux, Unix, Mac OS, free C++, written in which language? C++. Algorithms like regression, classification, clustering, support the term machine, dimensional prediction. Then Keras, if you see, Keras cross-platform, free Python API for neural networks, rapid miner, cross-platform. The cost is free. It written in language Java, data loading and transformation, data pre-processing and distribution. So top 5 algorithms of machine learning I'm going to demonstrate now. After that, we'll start the image classification, especially COVID-19, COVID strain and Omicron, and recently I'm collecting the data on PF7. So logistic regression, decision tree, support vector machines, naive Bayes, k-nearest. You see logistic regression, it is one of the statistical method. In this method, uses logistic function to model a binary dependent variable, although many more complex extensions exist. It is estimating the parameters of logistic model in form of binary regression. Logistic regression means the relations between the categorical dependent variable and are more independent with state variables by estimating probabilities using logistic function, which is the cumulative distribution function type of logistic distribution. Linear regression, logistic regression. See, put values x1, x2, x3, x4. That is called input to solve X. Linear model, probabilities, sigmoid function, values between 0 and 1. So this is the logistic regression algorithm I'm going to demonstrate. So you can download from the internet. Command prompt, go to command prompt, CLS. So go to website URL, see here. Google. You can see Python software. You can download Python software, go to this URL. See, go to download Python 3.11.1. See, now it is downloading. So now, see all of you, I'm going to install Python. Now you have downloaded from the internet. Now double click. So in the icon, you can select add path. There is a symbol I have already installed, that's why it is not shown. You can add these things while installing. Okay, now it is installed. Please see. Now see, see it is installing now. If anyone don't know, no problem. Python. See, I am installing the Python within 1 minute. You can run this Python. See, almost all done. So, latest version modified was successful. Now you can check whether this software is installed success or not. See here, go to run command here. See Python, type Python, you get 3.11. So one small program I'm going to show you. Likewise, you can execute many programs. Okay, suppose write a Python program. Write a Python program. Numbers using static. Very simple. Okay. Some a is equal to 3 and b is equal to 4, c is equal to n plus 1. Now see the c value. So same program using dynamic. Now see, I'm using dynamic. Small program. Then I will show you big programs. Dynamic program, dynamic input. So that is a static program. Write a Python program to perform addition of two numbers using static input. Write a Python program to perform addition of two numbers using dynamic. Same program. Int of, put of, enter value of e. Now I am reading the value. Next p value. Now p value is 4. Now same thing. C is equal to a plus b. B is equal to a minus b. E is equal to a star b. And f is equal to a division by b. G is equal to a percentile. Now check the values. My screen is visible. Please see here. Check the C. Yeah. See the C value, then D value, subtraction, multiplication, division, and modulo. So now, same programs I am executing. This Python can be executed in two ways. One is ideally integration development learning environment, and the second one is scripting way. Now I am going to show you scripting the same programs. Then now I'll execute the machine learning algorithms. So CLS, clear screen, same programs. Notepad is so with ap.ai, small program. Okay, I am creating small program by using Python. So I am using the now see my screen is visible. You can write a multi-line comment like Dr. Asadi Asadi, Srinivasulu. Then mobile number 9642260060. Okay, then aim of the program. Test. Aim I'm explaining. Write a Python program to perform arithmetic operations. Now I'm closing the full quotes. Now I'm using A is equal to int of put of and enter value of D. And P is equal to int of input of enter value of now same thing. A is equal to A plus B. B is equal to A minus B. B is equal to A star B. F is equal to A division by B. G is equal to A percentile B. Then print addition is equal to comma C output variable. Print. Then subtraction is equal to B. Then print multiplication E. Then division F. Print. A screen is visible.
Yes, sir.
So in this one, so after completion of this program, save control yes, then go to my file name is with the Python space print ap.py. See, now my program is asking enter value of A is 3, enter value of B 4. Now it is displaying addition, subtraction, multiplication, division, modulo, division, etc. Now I'm going to explain machine learning algorithms. See here. Now you are ready with the Python programming. See what I am using. Top 5 algorithms I am going to execute now. Logistic regression. It is based on the past values. We are predicting the future values. Import matplotlib, pyplot as PLT. Import numpy as NP. It's a numpy library, matplotlib library from scalar. So scalar is a library. From there, I'm directly taking linear model, import logistic regression, and logistic regression. From scalar matrix import classification, report and confusion matrix in order to check the accuracy of the problem. Import matplotlib.pyplot as PLT. I'm taking x value and y value. X value is between -1 to 1 and y value is 1. Print x and print y. Then I'm calculating model is equal to logistic regression of solver equal to linear, lim linear, random state 0. Model.fit of x comma y. Logistic regression, like I'm using all the parameters. Then model logistic regression, it's a comment section. This one. You can use this as a model. Okay. Now see, same program I'm executing, Python space logistic.py. So now it is going to execute. See, now I got the output. It generated graph based on x and y values. Generated predicted classes 0, 1. 0 means false, 1 means true. 0 means 0 means negative, or you can call it as positive. 1 means negative. Intercept value, quotient value, predicted value, etc. So that is a logistic regression. Next algorithm is, see, this is output executed. Then decision tree. It is also one of the data science and machine learning algorithm. It is just like a flowchart like this structure, where each internal node denotes as a test on an attribute, each branch represents an outcome of the test, and each lead node holds a class label. Decision tree. Induction is developed by Ross Miller. Decision tree algorithm known as ID tree. Creative diagramizer. So decision tree is classification in the form of a tree structure, decision node, if node, or etc. So these are the decision tree consists of decision tree induction, attribute selection methods, information gain, gain ratio, inheritance, tree pruning, scalability, and decision tree. So this is the data set I have taken, and this is the decision tree I have constructed for this data. Decision tree. So based on the age, we are classifying into 3 groups: student group, middle-aged groups, credit card rating, youth, middle-aged and senior. Then student is able to purchase computer or not, yes or no. Credit rating is fair or excellent. Based on that. No and yes. So this is a decision tree classification using Python. Okay. I have executed this algorithm. This is the output I got it. Decision tree algorithm. I am going to give you these things to you so that you can execute. Then support vector machine. It is also one of the classification techniques. There are supervised learning models. So based on the hyperplane, we are classifying the data. Then this is the algorithm I have taken. And I'm going to show you and demonstrate this one. See here. In this Python space, support vector machine. So this is support vector machine. Okay. So see here, I got accuracy. I have taken 61 samples of the data. 61 images I have taken, and I'm going to classify these images are positive images or negative images. So 35 images are positive images, and 26 images are negative images, and a total 61 images. Just for sample testing I have taken. Accuracy I got 50%, precision 0.45, recall 0.80. So likewise, we are classifying by using support vector machine. Then naive-based technique is also one of the classification or a collection of classification algorithms. And it is not a single algorithm, but a family of algorithms where all of them share a common principle. That is, every pair of functions being classified is independent of each other. There are 7 steps as follows. Start, separate by class, summarize data set, summarize data by class, Gaussian probability density function, class probabilities, stop, etc. So this is the formula we are using, naive-based classification. P of A by D equal to P of B by A into P of A and by P of B. Using Bayesian probability terminology, the above equation can be written as posterior is equal to prior multiplied by likelihood evidence. So this is the formula we are using. Likelihood of evidence given in that the hypothesis is true. That is P of E by H multiplied by P of H, prior probability of hypothesis and prior probability that the evidence is true. Posterior probability of the hypothesis is given, the evidence is true. So this is the data set I have taken, scalar, naive-based classifier, Python, Gaussian naive-based scikit-learn, etc. Naive-based technique. This is the code using Python. See, I am going to demonstrate now naive-based classification. CLS clear Python space naive-based. See, so if you see notepad space naive-based. So if you want to open this program, you can open naive-based on the IRIS data set. This is the code for Python I am going to share with you so that you can execute. So this is called naive-based classification. Then the last one here, support vector mission for heart disease patient data set prediction. Heart disease nowadays, because of COVID or any reasons, I don't know, so many heart attacks are happening. At least you can find a solution for a heart attack before getting heart attack. You can check the heart attack images you can collect and you can train as a model by using this support vector machine. And we are using the various parameters, fine-tuning parameters in order to classify the support vector machine. This is the data set I have taken, heart disease data set. Heart disease data set. Okay, so you can take as input to the and heart disease data set. So then you can execute this algorithm by using classification clustering algorithm. SVM2 I have used. See, CLS Python space. Let me check the SVM1 is not working. Yeah, it is also working. So SVM2 Python space code vector machine for a heart patient data set. Okay, so this is the output I got it for by using the support vector machine. Next fifth one is last one. Then I will start image classification using deep learning and machine learning. K nearest neighbor, K means assumption, number of clusters or classes. Is a very simple, easy to understand, and KNN algorithm used for both classification and regression. KNN algorithm based on the feature similarity approach. And if you see the diagram, beginning of k is equal to 1 for k and n. Algorithm steps like start, calculate the distance, find closest neighbors, vote for labels, swap, etc. And these are the k and n algorithm steps. Initial data, calculate distance, finding neighbors, and voting for labels, classifier masking. So this is the steps we are following. Classifier building in scikit-learn using KNN. So steps are 15 steps. Start KNN classifier, defining data set, encoding data columns, combining features, generating model KNN with multiple labels, loading data, exploring data. Let's check records of the target set, splitting data, generating model for k is equal to 5, model evaluation for k equal to 5, regenerating model for k, model evaluation for k equal to 7. Now see that this is the algorithm using Python, k nearest neighbor technique using Python. So k and Python model, I am going to demonstrate this one. Please see, I am going to demonstrate it. So Python space knn.py, k nearest neighbor algorithm. See, I got the results. 68 point. In order to increase the accuracy, you can do the fine tuning parameters you need to perform very well. So these are the top 5 algorithms I have executed. Now I am moving to image classification. Okay. My dear friends, any doubts? Please respond. Any doubts for execution of Python program? No doubts. If I provide you my PPT, can you execute it more?
Yes, sir.
And my dear friends, if you have mobile, please subscribe my channel. Nearly 40 to 50 participants are there. Just go to YouTube. Please take your mobile. At least you do a favor for me. Whenever you find a time, you can listen my videos. I have uploaded nearly 100 videos of various latest technologies. So please go to YouTube. Just type YouTube in Google if you are in the system, or if you are in the mobile, just type Dr. Asadi Srinivasulu. Please type all of you, my dear friends. Only 2 subscribed right now. Just type my name and take mobile and please type my name, Dr. Asadi Srinivasulu. Then click my channel. There are various videos I have incorporated. See here, number of videos. Then you find various latest technologies and cyber security, data, cloud computing, artificial intelligence, augmented reality, virtual reality, and Python programming. Various videos I have incorporated, and data science applications. That is my core area. Data science applications using machine learning and deep learning. So these are 100 videos I have created with the channel. If you are finding time, please listen and write comments on the video. Okay, so these are my videos. So now, how many participants subscribed? Only 3 right now. Please do it favor for me. So next we are Only three participants. If you are mobile, please subscribe my channel. Asadi Srinivasulu. Like and subscribe. We'll go to next topic. Image classification using deep learning techniques. So I think everybody knows deep learning. So deep learning is an extension of machine learning. It is a subpart of machine learning. Machine learning is a subpart of artificial intelligence. Learning can be a supervised, semi-supervised, and unsupervised. Deep learning gets its name from the fact that it involves going to deep into several layers of network, which also includes hidden layers. Okay, and which companies are using deep learning? See, DeepMind, reinforcement learning, they are using OpenAI, they are using transformers. Facebook, they are using self-supervised learning. They are using Auto ML. Apple, they are using federated learning. Microsoft, they are using machine teaching. Amazon, they are using transfer learning. IBM, they are using quantum machine learning. Okay, keep in mind. Why I am explaining very important. What it is, how it is done. See, in computer science, the study of computation and computer technology, hardware and software. What is meant by machine learning? Algorithms that can make predictions through pattern recognition. Deep learning, a form of machine learning that uses a computing model inspired by the structure of the brain, which requires less human supervision. How it is done? The brains of AI. Deep learning algorithms called neural networks, open source technology, large data sets, labeled data, engineering experts, specialized part. So, deep learning industries, AI now for every industry. There is an agriculture, healthcare, financial services, insurance, manufacturing, retail, recycling, etc. So machine learning use cases like finance, healthcare, media, retail, etc. So what is meant by deep learning? Learning from the observational data with a deep manner, huge number of input and hidden layers. That is called deep learning. See, what is deep learning here? So, if you are taking car as an input, it is extracting features and doing classification. It is identifying car or not. That is called the classification technique. If you see artificial intelligence, is a intelligent behavior in a machine. The science and engineering to develop various applications, intelligent applications. Machine learning is a subfield of a subset of AI. Deep learning is a subset of machine learning. Deep learning uses neural networks to simulate human-like decisions. So this is a small history. Artificial intelligence, nothing but engineering of making intelligent machines and programs. 1950s it came. Ability to learn without being explicitly programmed is called machine learning. The year 1980s it came. Deep learning, learning based on deep neural network. 2010s. Then who invented deep learning? In the mid 1960s, Soviet mathematician Alexei Ivankov created small functional neural networks, which is considered first release deep learning breakthrough. Deep learning is an AI function that mimics the working of the human brain in processing data for music, detecting objects, recognizing speech, translating languages, and making decisions. The ability to process large number of features makes deep learning very powerful when dealing with the special instruction. Enabling machines to think like humans, that is called artificial intelligence. Training machines to to get better at a task without explicit program is called machine learning. Using multi-layered networks for machine learning is called deep learning. Why use deep learning? See how do data science techniques scale with amount of data? So deep learning requires larger training data sets. If you take x-axis amounts of data, y-axis performance, using older training algorithms. Nowadays, deep learning algorithms. So deep learning is a subfield of machine learning concerned with algorithms inspired by the structure, the function of the brain called artificial neural networks. And while traditional machine learning algorithms are linear, deep learning algorithms are stacked in a hierarchy of complexity and abstraction. Curse of dimensionality means the data is a complex. The curse of dimensionality first introduce the delta indicates that the number of samples needed to estimate an arbitrary function with a given level of accuracy grows exponentially with respect to the number of input variables, each dimensions of the function. If you increase number of columns, number of attributes, records, the data becomes complex. That is called the curse of dimensionality, refers to various phenomena that arise when analyzing and organizing data in a high dimensional species that do not occur in low dimensional settings, such as the three-dimensional physical space of everyday experience. This example I have already explained for reinforcement learning. Based on the punishment and reward, we are solving the problem. It's called reinforcement learning. Deep learning process uses 5 steps. Understand the problem and whether deep learning is a good fit or not. Identifies relevant data sets and prepare them for analysis. Chooses the type of deep learning algorithm to use. Trains algorithm and large amounts of labeled data. Test the model's performance against labeled data. Deep learning model life cycle, data and labels, references we are using as a model, create update model, train and testing model, evaluate model. If it gives very less accuracy, then go for a repeat, then serve model. This is deep learning modeling life cycle. Deep learning pipeline. First, we are taking as input and data sent to these distributed storage streaming data with help of HDFS, Google Cloud Storage, SARSA, Kafka. Then users data preparation and analysis using the Jupyter, Apache, Spark, framework and cluster, deep learning tools and distributed hosting. Uses TensorFlow, PyTorch, etc. Models, building machine learning models, model serving, sending model to clients. These are the machine learning, deep learning tools. Machine learning programming languages like Python R, machine learning tools like TensorFlow and Scalar, Reka, deep learning tools like Keras, PyTorch, analytical tools like Spark, Hadoop, visualization tools like Matplotlib, Seaborn, Jupyter, etc. See the difference between machine learning and deep learning. Machine learning classifies the data, but it is not describing all the features. See the diagram, input as taken to the machine learning, then feature extraction, classification that you are getting. Is a car or not? Whereas in deep learning, you see deep learning concept, you are using same car as input to the system, but here we are increasing number of input and the hidden layers. Feature extraction plus classification. Finally, we are getting output like car, the car color, price, etc. These are the additional features we are extracting from through deep learning techniques. So deep learning versus machine learning. You see the examples factors. Data requirement in deep learning requires large data, whereas machine learning can train on lesser data. Accuracy provides high accuracy in deep learning, gives lesser accuracy in machine learning. Training time takes longer to train, takes less time to train. Hardware dependency requires GPU to train properly. It trains on CPU center processing unit. Hyperparameter tuning can be tuned in various different ways. Limited tuning capabilities. So these are the parameters I have explained. And perceptions. Perceptrons, you can call it as it is an algorithm for supervised learning of binary classifiers. So it is a type of linear classifier, classification algorithm that makes its predictions based on a linear predictor function combining set of weights with a factor value. What is meant by learning? The learning rate controls how quickly the model is adapted to the problem. See, the batch size is the number of samples processed before the model is updated. Batch size is a hyperparameter of gradient descent that controls the number of unique samples to work through before the model's international parameters are updated. The number of epochs is a hyperparameter of gradient descent that controls the number of complete passes through the training wheels. Activation function. The activation function of a node defines the output of the node given an input or setup. Single layer perceptron. SLP is a feed-forward neural network based on a threshold transfer function. SLP, single layer perceptron, is the simplest type of artificial neural networks and can only classify linearly separable classes with the binary target function. We see limitations of single layer perceptron. The reason is because the classifier in XOR are not linearly separable. You cannot draw a straight line to separate the points 0, 0, 1, 1 from point 0, 1, 1, 0. Led to invention of multi-layer networks. Importance of multi-layer perceptron. Multi-layer networks solve the classification problem for nonlinear sets by employing hidden layers. So whose neurons are not directly connected to the output. So multi-layer perceptrons are useful in research for their ability to solve problems stochastically, which often allows approximate solution for extremely complex problems like fitness approximation. MLP uses backpropagation as a supervised learning technique. Since there are multiple layers of neurons, MLP is a deep learning technique. MLP is widely used for solving problems that require supervised learning, as well as a research into computational neuroscience and parallel distributions. Pre-activation presented by A, it is a weighted sum of input plus bias. Activation represented by H. Activation function is non-linear function. Activation function is an activation function is a function that is added in an artificial neural network in order to help the network learn complex patterns in the data. When comparing with a neural-based model that is in our brain, the activation function is at the end deciding what needs to be fired to the next neuron. Back propagation is an algorithm used to calculate derivatives quickly. ANN used as a learning algorithm to compute a gradient descent with respect to weights. Next, the algorithm gets its name because the weights are updated backward from our gradient descent is the first order initial optimization algorithm for finding a local minimum of differentiable function. Gradient descent is an optimization algorithm for finding a local minimum of differentiable function. Gradient descent is simply, you can call it as so functions parameters, that is coefficient that minimizes a cost function as far as possible. We see the diagram learn gradient descent like gradient descent, x-axis weight, y-axis cost, and the derivative of cost, you can call it as initial weight and the incremental step gradient descent. See, what are the use cases of deep learning? Deep learning use cases, who are the using the worldwide? Used for knowledge discovery and predictive analytics. Includes, say, example, Google uses deep learning to build powerful voice and image recognition algorithms. Netflix and Amazon use deep learning in their recommendation engines. And MIT researchers uses deep learning for predictive analytics. Now see the diagram, especially deep learning industries, agriculture, healthcare, financial services, insurance, manufacture, retail industry, research. These are the deep learning use cases, especially face unlock in smartphones, selfie filters, networking, cab booking, Hey Siri, Google, personalized marketing, Gmail spam alerts, Play Store recommendation, online food delivery portals, etc. So this is a deep learning process. Input layer 1, L1, hidden layer L2, hidden layer L3, hidden layer L4, output layer L5. You may get doubts, sir, how many we can use? Input layers and hidden layers. As many as required for your problem in order to get the good results you can use. And W stands for weight. X1 to X3 and so on, followed by the XP. These are the input layers. Then hidden layers L2, hidden layers L3, hidden layer L4. Final output with the red color L5, Y0 to Y1 and so on, Y9. So this is a deep learning process. We see deep learning workflow. Lots of labeled data or unlabeled data are taking as input to the system. Training set under validation test. Training set learn deep neural network. Validation set for validating the data. Then pre-processing of the data set. Adjust parameters, network architecture, etc. We see deep learning process. I'm taking the year 1990s, how this neural networks works, and nowadays deep learning neural networks, how it is working. We see number of nodes is nothing but neurons here. It leads carry signals from one node to another, boosting or damping them according to each link's weight. Whereas the deep learning neural network, so we are taking as an input layer and identify light dark pixel value. See, I'm taking one scientist image as input to the system. This first level input layer takes the data, it divides into number of pixels, that is called identify edges, then identify combinations of edges, identify features, Then identify combinations or features. Then output layer use, oh, we use a George. That is the learning, deep learning process. There are three important algorithms: deep neural networks, convolutional neural networks, recurrent neural networks, providing a link for classification and forecasting models, feature extraction and classification images by using a convolutional neural networks, and for sequence of events, lag-based models, time series data, we are using recurrent neural networks. So deep learning models are two types: supervised models, unsupervised models. Supervised models are convolutional neural networks, classic neural networks, and recurrent networks. Unsupervised learning, self-organizing maps, Boltzmann machines, auto-encoders. So DNN can perform classification, deep neural network, prediction, and time series prediction. Whereas CNN can perform three: prediction and time series prediction, computer recognition, vision, and classification. RNN and LSTM, recurrent neural network, long short-term memory. It uses prediction and time series prediction and classification. This means CNN gives you complete image classification, especially. Deep learning methods like CNN-based methods, RBM-based methods, and autoencoder-based methods, sparse coding methods. CNN-based methods select nets, clarify 50 to 60 layers, SPP 26 layers, VGG 31, Google Net 2. Then RBM-based methods, deep belief networks, deep Boltzmann machines, deep energy methods. Autoencoder-based methods, sparse encoder, denoising encoder, contractive encoder. Sparse coding-based methods, sparse coding SPM, Laplacian sparse coding, local coordinate coding, super vector coding. So these are the mathematical formulas we are using: multiply rule, power rule, sum rule, differential rule, product rule, quotient. So these are the four models I have explained. So convolutional neural network is a type of artificial neural network, especially used in image classification, image recognition, and face recognition, biometric image applications, and processing that is specifically to process pixel data. Then RNN or type of neural network where the output from the previous step is fed as input to the current step. RNNs are mainly used for sequence classification, sentiment classification, and video classification. Sequence labeling for speech and named entity recognition. LSTM, long short-term memory. It is an artificial recurrent neural network architecture used in the field of deep learning. LSTM networks are well suited to classifying, processing, and making predictions based on time series data. Since there can be lags of unknown duration between important events in a time series. Yeah. Generative adversarial network, especially we are using GANs in how your face changes over the period. In childhood days, how you are looking after 5 years, how you are looking after 15 years, how you are looking, how your face changes over the period. Such type of applications we are developing with help of GAN. Generative adversarial networks, very important. It is a machine learning model in which two neural networks compete with each other to become more accurate in their predictions. GANs typically run unsupervised and use cooperative zero-sum game framework to learn. So these are the top 10 Deep learning tools we are using TensorFlow. I have already described about TensorFlow. Is a deep learning concept tool. One of the best frameworks. TensorFlow is used for natural language processing, text classification and summarization, speech recognition and translation and more. Microsoft Cognitive Toolkit, most effective for image, speech and text-based data. MCTK supports both the CNN, both CNN and RNN. Cafe, one of the deep learning tools built for scale, and the Cafe helps mathematicians to track speed, modularity, and expression. Then China, Keras, deep learning project. Keras is a framework that can learn both CNN and RNN. Keras is a popular choice for me. And the deep learning project is also one of the popular choice. Deep learning code libraries like TensorFlow, PyTorch, Sparky, Maximum. See here, we are using Beyond Deep Learning 4J ML.net, DeepMan, Piano, Microsoft CLTK. Next, why this Python is so popular? Because of rich number of libraries are presented, especially TensorFlow, Keras, PyTorch, Piano, they are using, and that's why it is so popular. So, what are the applications of deep learning? We are using instant visual translation, predicting the future values, chatbot applications, medical care applications, self-driving cars, read link movements, colorizing the images, photo descriptions, deep learning, deep dreaming, and advertising. So these are the latest best applications that use data, especially autonomous vehicles. Now even Google, Microsoft, IBM have started to perform autonomous vehicles. Tesla, Motiliomo already in the trial period, came already to the market. Poly-B, Noise, Grammarly, Meridian, Turela Brain, Juro Eyes, WaveNet, 6X, Toby, AI. So these are the top 10 fascinating applications. This is self-driving cars. They are using deep learning concepts. Automatic handwriting generation, pixel restoration, and the colorization of black and white images, deep dreaming, detection of growth delays in children, demographic prediction, sound addiction to silent films, news aggregation, automatic vision transmission. So these are few more applications. These are the applications I have explained. And the most useful deep learning tools like Neural Designer H2O, Deep Learning in Microsoft Cognitive Toolkit, Keras, These are the top 10 open source deep learning tools. Anomaly, fraud detection in transaction, LSTM, automatic image caption, recognition, the generation, CNN, speech, paid users get voice, RSFM, autism spectrum disorder in kids, Google Assistant, voice or keyboard, voice and keyboard virtual, machine learning, field-based vague identification. So these are the top 10 tools I have got. TensorFlow is developed by one of the company called TensorFlow organization. open source deep learning framework for the development of machine learning and deep learning models founded on November 9. Then Keras, okay, then PyTorch, OpenML, Microsoft Works, CNPK, Microsoft Cognitive Computing, Apache Mapping, Determining Kit, and Deep Learning 4J, and .NET, Played ML. So these are the libraries. Now I'm going to do practical sessions on the image classification using machine and deep learning algorithms. What are the challenges of deep learning? See here, learning without supervision is a challenge. Coping with the data from outside the training distribution is a challenge. Incorporating logic is a challenge of deep learning. Unsupervised and self-supervised learning, it is a deep learning challenge. Autoencoders, it is a challenge. To overcome these challenges, we are using a combination of frameworks like Keras, TensorFlow, PyTorch, Piano, Matplotlib, sklearn, scikit-learn, various libraries we are using in order to avoid these challenges. Then deep learning challenges like high performance hardware requirements, issues with flexibility and multitasking, data availability, non-optimizing hyperparameters, data security. These are the deep learning code libraries: NumPy, SciPy, scikit-learn, Piano, TensorFlow, Keras, PyTorch, Pandas, etc. Python libraries and frameworks. Machine learning. See here, NumPy. What are the libraries we are using for machine learning? NumPy, TensorFlow, Piano, Pandas, PyTorch, Keras, scikit-learn, Matplotlib, SciPy, CMOD. Then web development tools: Django, Flash, Bottle, CherryPy, Pyramid, Web2Py, TurboGears, Cubic Web, Dash, Falcon. Automation testing: PyUnit, Behave, Splinter, Robot, PyTest. Image processing: they're using OpenCV, Mahotas, Busy Magic, Simple TK, Scikit Image. Game development: Pandas, 3D, Pygame, PyOpenCL, Pyglet, Arcade, Web Scraping, LXML, and Quest, Selenium, Beautiful. These are the tools. NumPy, SciPy, Pandas, scikit-learn, Piano, TensorFlow, Keras, Python, CMOD, Matplotlib. And these algorithms KNN have executed. Now healthcare application, especially our core topic, digital images. Okay. So healthcare is the maintenance or improvement of health via the prevention, diagnosis, treatment, or amelioration or cause of disease, illness, injury, and other physical and mental impairments in people. Healthcare is delivered by health professionals and allied health. Efforts made to maintain or restore physical, mental, or emotional well-being, especially by trained and licensed professionals. These are the 7 image database applications I am going to demonstrate now. COVID-19 virus prediction and detection, Omicron virus prediction and detection using machine learning and deep learning, Ebola virus prediction and detection. I have taken X-ray and the CT scan images for all these 7 image database applications: prostate cancer prediction and detection, breast cancer prediction and detection, lung cancer prediction and detection, monkeypox virus prediction and detection. So 10 healthcare applications that you can build without coding, like online patient portal, disease management, patient condition reporting, health and wellness management, diagnostic, inventory management, research and development databases, digital transformation and productivity, knowledge-based system, and the laboratory management. So now I'm going to explain image database application, especially COVID virus. Coronavirus is an infectious disease caused by newly discovered coronavirus. COVID-19 is caused by a coronavirus called SARS-CoV-2, severe acute respiratory syndrome. COVID-19 is a disease caused by new strain of coronavirus. C stands for corona, VI for virus, and T for disease. Formerly, this disease was referred to as 2019 novel coronavirus. That's why it is called COVID-19. These are the symptoms of COVID-19: fever, cough, shortness of breath or difficulty breathing, chills, muscle pain, headache, sore throat, new loss of taste, congestion or runny nose, nausea or vomiting pain. So these are the clinical and image features of COVID-19 patients. Data set I have taken. Nearly 850 images I have taken, X-ray images. Then I have applied convolutional neural network. Step 1, convolution operation. What is the meaning of convolution? It refers to the combination of two functions to produce third function. Produce third function. You can call it as third function. And see, next, convolutional ReLU layer. So ReLU layer, rectified linear unit. That is a rectified linear unit. Is activation function to compute and predictable gradient path propagation of the error. Increases the linearity function in the context of convolutional neural networks. Pooling, it reduces the spatial size of representation and to reduce the amount of parameters. And also computation in the network, there are two types of max pooling and min pooling or average pooling. Flattening, it is converting data into one-dimensional array for inputting to the next layer. It will flatten the output of the conventional layer to create a single long feature vector. Step 4, it is to take reservable connection. It is to take the results of convolutional or pooling process and then to classify the image of a layer. So these are the 4 steps we are following precisely: convolution operation, pooling, flattening, full connection. So these are the steps I am following COVID-19 image classification. Feature extracted by transfer learning in Keras and Solid. This is problem definition, data preparation, feature engineering, training ML algorithm, testing, trained model deployment, etc. This is the input I have taken. Normal images. COVID-19 image pneumonia. So I am giving input to the system. The system has to recognize which image is, whether it is COVID-19 or pneumonia or normal. By using exception network and REST-like 15. Parallel deep feature extraction. They are using concatenated features. And finally, we are predicting normal or good. This is the corona virus training data set to the CNN. These are the X-ray images I have taken as input to the system. These are the steps I have used for CNN model. Step 1, import the required libraries. Step 2. Import the training data set, perform the feature scaling, transform the data, create a data structure with 60 time steps and 1 output. Import the class library and its packages, initialize the ECNN, add the LSTM layers and some code generation. And compile the ECNN, fix the ECNN to be the training set, load the COVID-19 test images data from 2015, get the predicted COVID-19, visualize the results of predicted and so this is the code I have used for convolutional neural networks. Import the sequential model analysis. Then training augmentation configuration, testing augmentation rescaling, generates batches of augmented image data, generator for validation data, evaluating model performance and testing data, corona testing data to the CNN model. Okay, and this is the chest X-ray of COVID-19 virus and severity levels of the images. And these are the number of epochs with accuracy and diagnostic. See, execution flow of COVID-19 data set. Data loss versus accuracy. Then execution time between COVID-19 virus data set versus number of processes. This is a COVID-19 data size versus accuracy. I'm going to demonstrate now. See, any doubt? CLS, COVID-19, check the folder. How many images are there? See, CNN file is there, COVID-19 test images, COVID-19 strain images, training part, testing part. Then we are executing this CNN. So Python space CNN.py. So we need to install pip install TensorFlow. It is asking how to install the TensorFlow. This is the way we can install. Now it is installing. So it is saying that this version is not suitable. So what I will do, CD space, I'll go to another folder. So this PC, save folder. So what is the file name? So like this, you can execute. So 1 second, I'm closing this one. You can go to here. So in this folder, COVID-19 CNN model. See here, COVID train images are positive, negative. These are the images, positive images. Then I'm executing this model. This is the path that you can CLS. Now see, direct Sorry. Let's check. So CNN we have. So Python school is CNN.py. So it install. Again, it is showing same error. TensorFlow, and it will install. It's the latest version I am using. So it install. So could not find a version that satisfies the required TensorFlow. So we need to install the 3.9.5. In that version it is supporting. Okay. So next, in that version I have executed COVID-19 folder and COVID-19 strain. It is a variant of COVID-19. The symptoms are same symptoms and extra some features like nausea, vomiting, diarrhea, etc. So these are the extra features of COVID-19 variant. Then COVID-19 strain input data set to the CNN model. These are the images I have collected. COVID-19 strain training data set to the CNN model. This is the RNN algorithm. Import the COVID-19 data, training parameters, network parameters, graph input, TensorFlow, then define weights, and these are the steps we are following for execution of COVID-19 strain virus severity levels of the images. So then prostate cancer detection. I have collected various prostate cancer images like symptoms of prostate cancer developed as the condition progress. The main symptoms like a cough that doesn't go away after 2 or 3 weeks, a long-standing cough that gets worse. These are the symptoms. These are the images I have collected. Prostate cancer input data set to the CNN model. So this is the training data set I have collected, and X-ray of prostate cancer of normal image. This is the classification of prostate cancer. Next, breast cancer. So breast cancer images and symptoms of the breast cancer. These are the images I have collected from various data sets in various places. Like Kaggle, GitHub, and UCI repositories, we are collecting the various images of the breast cancer. Then this is the training data set we are using, and X-ray breast cancer versus normal image. We are doing classification. Then this is the data set we are using. This is the program, CNN Python model we are using. Okay, and breast cancer final execution is CNN model. We got very good results. Then lung cancer prediction. So here also we are taking various images. See here lung cancer input image data sets we are taking with various features. And this is a training data set for CNN model. And X-ray of lung cancer versus normal image. And Ebola virus prediction. It is also one of the deadly disease most commonly affecting people and non-human primates. Ebola virus is a deadly disease with occasional outbreaks that occur primarily on the African continent. These are the symptoms of the Ebola virus. See, Ebola virus symptoms: headache, heat, abdominal pain, sore throat, rash, loss of appetite, vomiting, bleeding, etc. Then these are the symptoms of Ebola virus: fever, muscle pain, vomiting, abdominal, area, and unexplained hemorrhage, bleeding, and those Ebola virus images are collected from the very big repositories like UCI, GitHub. Okay. And this is the RNN, recurrent neural network I used for Ebola virus detection. And see training parameters, network parameters. This is the algorithm. And I got a very good results for this one. X-ray of Ebola virus versus normal image. So finally, I'm concluding this theory part. After that, we'll see some practicals. So total 960 images I have taken. We have found 149 COVID-19 positive cases, and the remaining 230 pneumonia positive, and 250 for normal and negative. And so this is the thus we conclude that this model achieved an average accuracy of 89.62 and 91.54 sensitivity, and COVID-19 class, then overall accuracy of 88.4, 2 positive false. So with this one, theory part I am concluding. See what are the various FDP seminars I have conducted so far in the worldwide. So this is at Thailand, and this is at Singapore. I have conducted and acted as a keynote speaker. This is at Philippines. This is the keynote speaker at the engineering college. This is at Madanapalli. This is at Sri Vidyaniketan Engineering College. This is a jury member at Madanapalli. This is keynote speaker at one of the engineering college. Doctorate degree from JNT Anantapur. Bharat Vidya Ratan Award from Delhi. And ITAP Best IT Teacher Award at Hyderabad. And this is Best Local Chapter Award from IIT Madras. And this is an international seminar at Salem. This is one of the engineering college at the Gautami Institute of. I acted as a resource person. Then resource person at the IISER, Indian Institute of Science, Education and Research, Tirupati. Sangam University, I have explained big data analytics using Spark, and ABS Engineering College as a keynote speaker for big data analytics using Spark. Jaya Engineering College, one of the resource person, data analytics using Spark. And Maharshi Markandeya University, topic you can big data analytics using the Spark. Data science at the research talk at Bluecrest University. It is at Oman, big data analytics using Spark. Data science applications hands-on. This is at the Russia School of Scientist COVID-19 virus, strain virus detection. Udal Federal University, Bluecrest University 2 days symposium, big data application. This is at the Ural Federal University at Russia. This is data science application practicals at Bluecrest. This is at the Bharati RE in Coimbatore. This is Lord's Institute of Technology, data science using R programming, Eva University, Tampaga Vinayaka College of Engineering, Vijnana Bharati, and Bluecrest University in West Africa, 49 universities.
you are not audible. You are on mute. Sir, please unmute your device. You are not audible. You are on mute, sir.
So these are the various webinars I have conducted all over the world. It is at Woman, this is at the Met Institute, and this is at one of the engineering college, Babu Rao Ganpat Rao at Maharashtra. This is SSN Engineering College, Marshi Markandeya, and this is at the Council Engineering College. College. And my screen is visible. My screen is visible. And this is, but it's not moving. These are the various colleges. And the last slide, this is at the New Horizon with this is last with the AP. So with this one, I am concluding a session. Sir, Kupuswamy sir, are you there?
Yes, sir. Yes, sir.
Yes, sir. I have taken more time.
Yeah, you know, it's okay. It's okay.
Yes, sir.
Are you completed now?
Yes, sir. Any doubts with the participants? Let them ask, sir, please.
Yeah, sure, sure. Dear participants, if you have any doubts, you may ask for 5 minutes.
Yeah, please. Any doubts, my dear participants? Any doubts? Please ask any doubts. Or you understood very well about machine learning and deep learning concepts? Respond.
Yes, sir.
Yes, sir. And any doubts, please ask me, sir.
I hope they have understand about the machine learning and deep learning techniques. And also you have given some basic from the Python, how to use Python packages and machine learning packages and deep learning packages for the beginners to handle the classification approaches and to handle the images. I would like to call upon Manisha Madam to give a vote of thanks to the resource person.
Finally, we have come to an end of this first session of this activity. It was very valuable and informative, sir. Thank you so much, sir, for sharing your knowledge with us.
Thank you, madam, for giving me this opportunity. Thank you, sir, Kupuswamy sir, for organizing such a wonderful one-day national level activity on machine learning techniques for image classification. Thank you, sir, for giving me this opportunity.
Thank you, sir. Thank you, sir, for accepting our invitation, and also all the way because there is a very early morning. Among that, your schedule also you have given a wonderful lecture to the participants. So, on behalf of VAP, Scope I would like to thank once again all the participants and especially to our research person. Thank you, sir.
Dear participants, a Google form link is shared on the chat box. All are required to fill the feedback form for e-certification. And the second session will probably start at 2 o'clock. So all are requested to join with the same link. Thank you.
Yeah, thank you, madam. All dear participants, please join at 2 o'clock sharply. We will start at 2 o'clock the second session. Thank you all.
Sir, I am unable to view chat option.
Yes.